Hey folks, today we're going to be working on Leetcode 26, remove duplicates from sorted array. In this problem, we are given an array of integers that may or may not have some duplicates, but the array is sorted in non-decreasing order. It's kind of messy. Let's, scrunch it in. Yep. There we go. That's better. So as usual with these array type problems, we're going to have some pointers. We have a left pointer. We have a right pointer, as in W-R-I-T-E, and a right pointer, as in R-I-G-H-T. As we iterate through this array of integers, we just have one question we need to ask. Is nums at the left pointer equal to nums at the right pointer? And we're going to use that question to solve this problem. Okay, so here we have our problem. Once again, this is Leetcode 26, remove duplicates from sorted array. And we have our nums array here. As we can clearly see, there are quite a few duplicates. We have a couple of pointers that we're going to use. We have our left pointer that we're going to start at index 0. We have our right, as in W-R-I-T-E pointer, which is going to start at index 1, because we would definitely have no need to overwrite anything at index 0 because you can't be a duplicate of yourself. Man, I feel like there's like some sort of quantum entanglement thing that we could apply to this. But anyway, I don't know anything about that, but I did stay at a Holiday Inn Express last night. So maybe we'll talk later. We also have our right pointer as in R-I-G-H-T, and that is also going to start at index 1. And as in a previous problem, we're just going to keep track of nums at our left pointer, nums at our right pointer, and I wrote this here, nums at the right, as in right with your hand. Do we need to keep track of what's there? The way we're coding this, no, we do not need to keep track of that. And there's actually only one question we need to ask when solving this problem. As we iterate through, is nums at the left pointer equal to nums at the right pointer? That's the only question we need to ask each time we go through the iteration, and that's going to help us solve it. So let me show you how we do that, okay? So if they are equal, all we want to do is increment our right pointer, as in R-I-G-H-T, right? Because if they're equal, well, we need to overwrite the value that's the duplicate, but we need to find the next available value. So we're going to increment our right pointer, and I'm now thinking that maybe I should have named that like pointer 1 and pointer 2 instead of left and right, because then we have right and right pointer. Could be a little confusing. And for that, I apologize. So let's just go ahead and start iterating. So our right pointer gets incremented to 2. So now what is it pointing at? What value? Oh, we're pointing at 1. Now, see, I ran out of 0 tiles, so I had to borrow an O. I hope you don't mind. Okay, so now we ask the question, are these two equal? No. Well, this is when we actually get to do some work now. So we're going to set nums at our right pointer to the value of nums at our right. You know what? I'm going to rename these variables. We're going to name this William and Reggie. Okay, so that way we stop saying right and right. Let me just write that right here. So WP equals William and RP equals Reggie. I think that'll help us a bit. Okay, so we're going to overwrite the value at our William pointer with the value from our Reggie pointer. So here we go. We're going to take this 0 away, and we're going to put a 1 there. Now that we've done some work, we're going to go ahead and increment our left pointer. And our William pointer is also going to get incremented. And now that we've updated left and Reggie, let's go ahead and make sure we increment these values. Or not increment, update these values. So left pointer is pointing at 1. So let's grab a 1 tile. Hopefully we don't run out of those. A lot of 1s in this problem. Drop my tile. So we updated this. Now our Reggie pointer, 0, 1, 2, is pointing at 1. So we can just leave that the same. Now we're going to ask our question again. Are they equal? Well, yes, they are. So the only thing we do is increment our right pointer. Shit, Reggie. I'm going to have to censor that out. Anyway, 0, 1, 2, 3, still pointed at 1. Reggie, you're getting promoted. There we go. So now 0, 1, 2, 3, 4, still Get them printed to 5. 0, 1, 2, 3, 4, 5. All right, finally, Reggie changed something for us. Let's get a 2 in there. Okay, and now that they're not equal, remember, this is where we get to do our work. So we're going to update nums at our William pointer. So 0, 1, 2. You're not 1 anymore. You're going to become the value at our Reggie pointer, which is 2. Let's grab a 2. And then we just continue this process throughout the length of the array. So let's go ahead, pop over the IDE, see if we can make some sense of this with some Python code. And I'm definitely going to rename those variables because they are super confusing. Okay, folks, here we are in Leetcode's IDE. We are going to write the code up for this one. And honestly, it says this is an easy problem. And you know what? It is. But let's not just try to memorize this solution. Let's use the techniques we use in this solution, and then we can apply them to more advanced problems. So here we go. We got our left pointer, right? We're going to go ahead and set that to 0. And remember, we have our right pointer, and I am going to actually write that out so that we're not getting confused. Okay. So we've got that set to 1 because remember, we don't care what's at 0. There's no reason we would change what is at index 0. So we get to start the right pointer at 1. So now let's get a better name for our RIGHT pointer. So let's say for read pointer in range, starting at index 1, and then the length of nums. Okay, that's much better. A read and a right pointer and a left pointer. I like it. Okay, so what are we going to do? Well, remember, we said the only time we're going to do work is if those two values are not equal. So if nums at our left pointer does not equal nums at our read pointer, right? And let's make a firm memory of this. Make your variable name something that makes sense to you. So that way you're not in the middle of a problem. You're debugging it, and then you're like, oh my God, I don't know what the difference is between right pointer and right pointer, and I'm losing my mind. Just write them out. It takes a few extra bytes. Who cares? Just write it out. Do what works for you. Okay. Got off track there. So if those two are not equal, then we take nums at our right pointer, and we set it to nums at our read pointer. Right? Isn't that what we said? I think that's what we said. We'll find out soon enough. Okay. And then we're going to increment our left pointer by 1, and we used the right pointer. And so we're not going to just leave it there because we don't want to overwrite the value that we just overwrote. So we're going to increment that one too. Oh my gosh. There we go. Okay. And lastly, something we didn't discuss in any of the walkthroughs is we have to return an integer k showing how many unique elements were in the sorted array. And luckily for us, the way we're doing this, our right pointer, each time we write with it, that is effectively a count of each unique element. So at the very end, we just get to return our right pointer. And let's see what people think of this. Name WP, and there we go. I did not write it out. That's what happens. Right pointer. Let's try it again. And there we go. So it's nice and happy. We'll hit submit. Time complexity should be big O of n, right? Because we iterate through the array once. Give them a thumbs up. Thank you, Leetcode. Thank you. And this time, actually find the memory complexity. It's right there. And this should be constant space because we didn't use any data structures. So I'd give you 2 thumbs up if I could, but I can't, so I won't. Bye. I like it. Okay.